Welcome back, everybody, to our next day of webinars. I'm happy to welcome you all back. I hope you had an exciting first 2 days of the EREC. And today we will go on with Rogier de Klein from AMCS, and he will talk about a little bit about smart waste collection based on forecasting algorithms and Internet of Things. So I'm really excited to hear how that will work in the future. And yeah, I think we will have a lot of savings and interesting new technology bringing this forward. But before we start, one more thing. I don't know who of you have seen it, but at EREC we have a little raffle going on. You can win a few things. If you go back to the EREC page after the webinar, you can find in the head bar, you can find the tab where it's all described. You have to find a few numbers all over the whole EREC, and if you can find all of them correctly and answer these to us till the end of the week, you will be in for some nice prizes like an subscription of our Global Recycling or EU Recycling magazine, as well as some other prizes. Yeah, thank you very much for joining. We will just start now with Rogier de Klein, Smart Waste Collection based on forecasting algorithms and Internet of Things.
This presentation is around smart waste collection based on forecasting algorithms and Internet of Things. And it's supposed to cover how companies can reshape and optimize their waste collection through adopting these innovative technologies. My name is Rogier de Klein. I'm an intelligent optimization solution advisor at AMCS Group, and I'll do the presentation. First of all, I'd like to run you through some of the main trends and challenges we see within the industry and among our customers. There's a couple of major themes that make companies look towards collecting their waste differently. One of the major ones is urbanization, where we see that basically more and more people are moving into cities and rural areas, which means that the household waste collections are moving much more towards high density areas, and yeah, that brings complexities with it, leading towards adopting innovations. I'll run you through some of those later on in the presentation. Another major topic, obviously for most, is sustainability. How do we ensure that households produce less waste, and if they produce waste, how can we separate that as well as we can, in order to meet goals for using waste as raw material. A third one is a challenge to be as productive as possible. How can we ensure collection of as much waste per hour as possible? And fourth and last on this slide, obviously we try to do that as efficient as possible. That means that we only want to collect waste from containers where it's needed, minimizing vehicle movements and making sure that we can collect the waste using the minimum number of resources necessary for the collections. One of the solutions that was introduced specifically around this is underground waste containers, where the large volume of waste sits under the ground. That's why they are called underground containers, with a column on top for the disposal of the waste through either a valve or just an opening. And basically they are used to collect waste from multiple households in one and the same container. Obviously, as you can see on the picture as well, the collection of these containers require a specific type of vehicle with a crane installed on them to basically pick up the container from under the ground and empty it in the vehicle. Immediately that makes a couple of challenges quite obvious. So one of them would be a question around where to place the underground containers, and major considerations in where to place the containers are around how much distance should we aim for between the households and the containers to make sure that they are bringing as little waste as possible, and that they are basically motivated to separate their waste better. Another challenge then is, as the container is sitting under the ground, and if we only want to collect the container when it's almost full, how do we even determine how full an underground waste container is? And the next question would be, when do we actually go to a container to empty it, in order to make the collections as efficient as possible, but at the same time making sure that there's no overflowing of containers, etc. So those are challenges that come from basically a solution that was brought in with the underground container. And I'll try to cover how to meet these challenges in the rest of the presentation. First of all, where do we place the containers? It can be quite an exercise. And we have basically seen that with our solutions we can help to basically optimize the placement of the underground containers, and that starts with a basically very structured process where we do need a lot of data. That data is processed in our software solution for simulation purposes, and basically the outcome of those simulations could be that it points where to put the containers, and I'll run you through a bit more on that. First of all, it requires a lot of data in the software on where the households are. So in this example, it's Dutch data, which is called BAG, which is the base administration from municipalities on where the households are located. We also use data in this process from what is called PADOC in the Netherlands. It's the public domain on the map. Basically, that means all kinds of public facilities under the ground, like sewer systems, etc., that limit the placement of underground containers or possibilities for that. And those data is all used as a restriction, basically, and as input for determining the locations for the containers. Next is basically that we can, through multiple settings, run various scenarios with different sets of parameters, like the distance from the households to the containers, the number of households that would be served by an individual container. And by doing so, basically the solution can calculate and suggest placements of underground containers. And that's what it basically does on a map like this. These are all theoretical locations. So it might be that if you go to the actual location and see that a collection vehicle would have many difficulties in reaching a certain container, you could easily drag and drop a container to basically be on around the corner, which is maybe much easier to reach by a collection vehicle. So basically that process extends towards a tablet where the container locations are loaded onto a tablet and where a field representative can actually move around those container placements because of it needs to be around a corner for easier access by a vehicle. That is basically how we have helped several of our customers in determining the placement of underground containers. Next up is how to determine filling degrees of them. So as soon as the container is under the ground and being used, it is filling up. And what we have seen, basically, there is various ways and various different types of technologies available that may help to determine how full a container is. One of them is that some of these containers are equipped with access control systems where basically an inhabitant has to present a card, an identification card, on the container, and only when that card is presented, the container opens up and is available for waste disposal. So basically that means that every time a card is presented, the container fills up by an X%. The second option we see a lot in the field, and which is a bit newer technology, that's based on sensors, and basically that is an ultrasonic sensor fitted inside of the container, and uses ultrasonic waves to measure how full the container actually is. So it measures volume. And the third is weighing. Most of these collection vehicles with a crane, or many at least, have a weighing system on board of the truck. So that means that each and every time the container is lifted, we can at least determine the weight of the container when it's emptied. And these are all different ways of basically determining how full a container is. It might be worthwhile to mention that we see a lot of these technologies spreading out towards other waste collection practices. So it's not limited to underground containers. It's just the example I use in this presentation, but other types of waste collections could lend themselves just as well for using these IoT kinds of technologies to optimize basically the waste collection. So when we know how to determine how full a container is, the next question would be, yeah, how do we decide when to empty it, and how do we actually organize that? So one thing is that we have identified is that we have that we should do that based on a very structured approach and process, where what we see is most effective is that we try to determine based on historical data the typical pattern for a container with which it fills up. So one container may fill up in a couple of days, another one may need 2 weeks to fill up, and basically that is what we call the forecast on container fillings. So we build up those forecasts based on historical data. Then we use one of the measurement technologies I introduced on the previous slides. So either a volume sensor or access control systems to determine how much waste should be in the container at a specific moment. We plot that on the forecast to know basically, are we basically running ahead or behind the forecast, and that is used to determine when a container should actually be emptied. So how much time does a container still have until it overflows? And that basically determines when we need to collect it, or when we could at least consider it for collection. Then that is used to create orders, collection orders for those underground containers. And in our case, we have a software solution that covers this entire process from forecasting to basically creating the orders based on the actual filling degrees. And automatically those orders are fed into our optimization engine, which then optimizes the collection routes for the waste containers. And that's the process that has proven itself as being very effective, and companies adopting this for their underground collections have been very successful in doing so. I'll jump to some examples of that later on. Just in a bit more detail, this is what a forecast graph might look like, where you see basically the increase of filling degree over time. and that we actually use the current filling degree to determine, hey, is it ahead or is it running behind? And based on that actual filling degree in combination with the forecast, how steep is that slope, basically, how quickly does the container typically fill up, that is used to create the orders. We typically split them in two types. Must-do orders are the ones that actually need collection on the first available route. And the can-do orders, or first collection day maybe, can-do orders are the orders that we consider at a bit lower filling degree. They have a bit longer before they actually need to be collected. But when obviously the truck goes out and it serves a container very nearby, it might be more efficient to take it on a lower filling degree on that same day than having to send out an additional vehicle a day after or 2 days after to do that separate collection. So by splitting the orders in must-do and can-do orders, we can have a multi-day view of the plan and optimize it across several days. That's an interesting and powerful way of dealing with that. So that's a bit about the technology and the processes of determining filling degrees and how to get to collection routes and how to optimize that. Now I'll jump a bit more into the solution we have to support all this. So a bit more about the actual features in the solution itself. On a high level, it's a very simple solution, which basically has 6 main web portals as access to the solution. Obviously, we have to set up things like the resources, like drivers and vehicles. In the end, the solution creates collection routes. They need to be driven on a truck. So a mobile, in this case, a mobile web is the mobile solution for the driver to actually be able to drive the routes on a tablet or on a smartphone. So he has the route digitally available to him. And in the end, in the back office, all kinds of KPIs can be viewed for monitoring and managing the business based on the KPI dashboard that is part of the solution. And all the container locations and management of that is done in the site manager. So it's a very straightforward setup. And if we jump into them, obviously we need to set up those resources, drivers, vehicles, and part of that is setting up the calendar in which they are available or unavailable. A second part is all those container locations, the sites, which is part of the solution where we actually have a map view of the sites, but also obviously on the map we can see where what containers are located, what their capacity is, what the fraction is that is collected in them. Maybe if a site has more than one containers, that would be visible here and managed here. So that's part of it. And obviously an important one is that forecasting of the filling degrees, and that's what we see here. The solution shows basically on the left all the forecast for an individual container, and it is quite a clever forecasting solution we have put in place, because what we see is when you, for instance, use a volume sensor in a waste container, it often creates quite raw data, and the raw data might be with all kinds of weird fluctuations in there, because waste actually it might tumble inside the container, which shows a different volume. It might collapse on itself, and that makes reading those volume data quite difficult. So we have basically a cleaning mechanism as part of the forecast, which makes the data much more usable and much more user-friendly as well to read. And that's basically a part of the solution to to cleverly interpret basically the data that comes out of, in this case, a volume sensor, for instance. If we go into a forecast in more detail, basically what we see here is that it combines, or the solution combines the actual measurements of the filling degree, which you see on the left in yellow, and then up to the point where it has actual filling degree measurements. Then from that point, the forecast takes over in the graph, and you see the blue line basically shows what the forecasted increase in filling degree is, up until a point where the collection is planned, right? Then the container is emptied, so you see the sharp drop with the blue line, and then the forecast predicts that it starts to fill up again. And that's basically what a forecast means, right? And how it is used in the solution. So the forecast is there, and then basically all the time we get the actual sensor messages, and we use those and then extrapolate based on the forecast to determine when it needs to be collected. And that when it needs to be collected basically means an order, right? It's a collection order. And the solution automatically generates those orders. As I suggested earlier, typically two types of orders, must-do orders and can-do orders. Here you see on a map view how these orders are represented. So it literally shows the can-do and must-do orders on the map here, with the green for must-do and the yellow for can-do orders. By hovering on them, you can get more details about the individual orders and how full the container is, etc. But it's a clear overview of the area that needs to be served and the orders that need to be collected in that area, and that's part of the solution as well. Then from practice, we know that every once in a while there might be a container that needs to be inserted into a plan on an ad hoc basis, based on a phone call by a neighboring household or whatever, with a complaint of overflow or whatever it may be. But the container can be added through an basically manual ad hoc order process, which you see here. You can just select the container and add an order for it, and then it automatically gets part or becomes a part of the orders that needs to be planned and is used in the optimization as well. Then basically the solution itself creates the optimized routes in the background. You don't have to really interact with the solution to get the planning done. It just runs in the background, and it creates the collection routes based on the orders that were created. And what it does through a user interface like depicted here, it just shows the results of that. So it shows how much a vehicle is utilized, how many stops are on it, how much waste it will collect, how long the route will take, and obviously we can see the route on the map or in a tour list, all that kind of stuff. But it's more like a user interface that presents the outcome of the planning and allows a planner to manually adjust it instead of having to focus on building the plan. So that's just a core strength of the solution, that it can do that automatically. If we look into that into a bit more detail, then this is what you get to see. You see the various collection vehicles with the results of the planning. So in the first bars, we can actually see how well they are utilized. So how much are they driving? How much are they serving containers? Is there a lot of waiting time in the plan? That's what we see there. Also followed by KPIs to support that. And obviously we can go into the map and the tour list to see more details for the individual routes. And that's what you see here. Basically a route list on the left, route on the map on the right. And this allows a planner to adjust some of the planned routes. So it might actually drag drop an order to change the sequence of a route or whatever. So some light planning facilities are available, but the core of the solution is around automatic planning. So it's very much around maybe managing an exception here or there. Obviously, routes need to be driven by a driver, and every once in a while a driver reports sick or something happens. So in the solution, in a very simple web portal setup, you can just assign and reassign routes to a driver so that it is available in his mobile web application, for instance, for execution on the smartphone. And that's what you handle and manage here. Then if we look at the mobile solution itself, it shows a route list and a map, just as we saw in one of the previous slides, but this is then specifically aimed at using on a mobile device. So that might be a tablet, for instance. And then you get a route list where and the route on the map. If the driver selects an individual order on his route, he will be shown the order details, like where is the order, what is the planned collection you'll do in terms of fraction, in terms of weight, and the solution might also offer facilities to take a picture. For instance, if a container cannot be reached because it's blocked by another vehicle or waste that's placed outside of the container or whatever, he might have to cancel the order, but then at least add a photo to basically document why he couldn't serve that individual container. So that's all part of the mobile solution. That's an integrated part of the total solution stack for these IoT-based collections, if you like. And then basically the solution ends with a KPI dashboard in which you basically see the main KPIs depicted for instance, last week, today, and next week. That's what is shown here. How many routes do we have? How many collections are on the individual routes? How much weight do we collect with the route? How many bins are over 60 or 70% full? And also looking towards today and to the future, it shows the similar KPIs. It might be, and that's just from practice, that we have seen that some of the containers are out in the field so long because they fill up so slowly that actually a municipality or a waste operator might actually have to limit the time that is between various emptyings. So that makes a container collected dynamically based on its filling degree, unless unless it takes longer than 2 or 3 weeks or whatever that period may be, to basically, and that is aimed to limit, for instance, smell from a container and other complaints that might come from leaving a container unattended for a very long period of time. Also, the solution covers that there's seasonality in waste offering, basically. So you could have seasonality patterns as part of the planning solution, which ultimately means that the container forecasts are basically different in various periods in the year, and that obviously leads to other collection routes, if you like, but it facilitates that seasonality and functionality is there to basically make sure that whatever the season is and what that means for the offering of waste, that is covered by the solution. So that's a bit about the how and what we try to achieve with it. As a last part of this presentation, I'd like to share some of the cases that we've seen at our customer cases and some of their results. to show you that this is actually very worthwhile when considering smart ways of collecting waste in a smart city. And one of the first, or maybe the first even, in the world to adopt dynamic collections like these for underground household waste containers. Again, this could be used for for any type of container, and IoT is in that sense really gaining ground, if you like. But Twente Milieu was one of the first, or the first, to adopt it, and they are an organization in the east of the Netherlands, serving 6 municipalities. They serve 185,000 households in that area. Roughly 1,400 underground waste containers are used in those 6 municipalities. And they have, back in 2013, adopted the first, or as a first company, the dynamic collection of those underground waste containers. Before that, they just did collections based on fixed patterns for the containers. And the results since then have been very impressive, I'd say. The filling degrees when we started with the project were around 50% on average when emptying. And they have been increased to over 85%, but because the municipality came back to them and suggested that some of the containers needed to be picked up on frequency basis if the filling degree wouldn't, or the filling wouldn't, or the container wouldn't fill up quickly enough. That meant that the filling degree has now on average dropped to a little over 80%. But all in all, still very impressive, I'd say, moving from 50 to over 80%, and previously even to over 85%. In terms of productivity, we've seen that Twente Milieu has just increased the waste collection per hour by over 25%. So more than 25% more weight or volume is collected per hour. And all in all, the waste collection is done with much less miles, and overall we see a reduction of 35%. And at the same time, they reduced the number of complaints about overflowing containers to 0. So they have no complaints on overflowing containers anymore, while at the same time boosting their productivity and efficiency with some quite impressive figures. We have more on the case study on Twente Milieu on our website. You can read quite a lot on it there if you follow that link. Another example is Omrin. That is a waste collection company in the north of the Netherlands for 18 municipalities, 207,000 households. They have more recently adopted the basically dynamic collection of waste containers, the solution we have for that. But already they have seen the filling degrees go up from 60 to 80%, have significantly improved productivity both on the trucks side and in the back office, but most notably on the truck side, where they have been able to serve a lot more containers, with areas being equipped with these underground containers without actually having to invest in additional vehicles. They have been able to stabilize their customer servers and at the same time improve it as well. And that basically comes down to less or no overflowing containers, just like in the case of Twente Milieu. And also they reported that they have achieved less mileage, less stops, less fuel consumption, and less CO2 emissions as a result of all that. All because of the optimization they have achieved with the solution. And it is part of a more large-scale program within Omrin around sustainability. And obviously they are doing a fantastic job, because in 2019 they were awarded a Most Sustainable Company in the Netherlands award for being the most sustainable company. So that's quite impressive example of what you may achieve by adopting these technologies and using them for dynamic collections, which in the end means just optimization of the collection business. Also for Omrin, we have additional information on our website. There's a customer testimonial video, which you can see if you follow the link at the bottom there. That is the end of this presentation. If you feel like you want to ask questions or interact with us in more detail about that, please contact us or me at rogier.deklein@amcsgroup.com. Thank you for now.
Well, thank you, Rogier. Of course, you can all head over to AMCS, to the AMCS booth at IREC, where you will find the contact data as well and can even contact them through the live chat. Thank you all for watching. See you at the next webinar. Bye-bye.